Hello and welcome to Computer Science 4DS. This is Greenfoot book, chapter 2, first program, Little Crab, and I'm reading on page 17. And before I begin, just want to remind you that you have a worksheet as well to complete at the end of the lesson and turn it in and I will mark that for you. Okay, in the previous chapter we discussed how to use existing Greenfoot scenarios. We created objects, invoked methods, and played a game. Now we want to start to make our own game. And the scenario we use for this chapter is called Little Crab. You'll find this scenario in the book scenarios folder. The scenario you see should look similar to figure 2.1, and I've got it up on my screen here. And in exercise 2.1, you're supposed to open that, place a crab into the world, and run the program. There's my crab. Let's just run it, and this is exactly what should happen. Nothing. On the right, you'll see the classes in the scenario. We notice that there are the usual Greenfoot actor and world classes. They are here and here. And subclasses called Crab World and Crab. Of course, Crab World is the sandy world here, and the crab is one of our actors. The hierarchy denoted by the arrows indicates an is-a relationship, also called inheritance. A crab is an actor, and a crab world is a world. Initially, we will work only with the crab class. We'll talk a little bit more about the crab world and actor classes later on. If you've just done the exercise above, then you know the answer to the question, what do you observe? And the answer is nothing. And the next page on page 18 shows exactly what I've got on my screen. The crab does not do anything when Greenfoot runs. This is because there's no source code in the definition of the crab class that specifies what the crab should do. I'll just show you that. Here it is here. When you hit act, it does nothing. In this chapter, we'll work on changing this. The first thing we will do is to make the crab move. So on that page 19, 2.2, making the crab move. Let us have a look at the source code of class crab. Open the editor to display the crab source. You can do this by selecting the Open Editor function from the class's pop-up menu, or you can just double-click the class. The source code you see is shown in figure 2.1, and I have it on my screen as well. This is standard Java class definition. That is, this text defines what the crab can do. You will notice the different colored backgrounds. The whole class definition is enclosed in a green box, and within it, every method definition is in a separate box with a yellowish background right here. There's also a separate statement at the top before the class definition on white background, right up here, import Greenfoot. We'll look at this in more detail later. For now, we'll concentrate on getting the crab to move. Within the class definition, we can see what is called the act method. The bit in the yellow box, it should look like this, public void act. The first line is the signature of the method, this one right here. This is called the signature. The last three lines, the two curly brackets and anything between them is called the body of the method. Here. Here we can add some code that determines the action of the crab. We can replace the gray text in the middle with a command. One such command is move 5. So right in here, I'm going to remove this, and I'm going to type move 5, like so. And you'll notice that I left one thing out. It's got a little error message here. It's expecting that semicolon, so let's put that in. Turn the page. Note that it has to be written exactly as shown, including the parentheses and the semicolon. The act method would then look like this. So exercise 2.2 says change the act method in your crab class to include the move 5 instruction as shown above. Compile the scenario and place the crab in the world and try clicking the act and run buttons. Remember that it's automatically compiling now, so I'm going to place a crab in here and I'm going to run him. And he moves 5 spaces at a time. If we change in exercise 2.3, if we change the number 5 to a different number, you'll get smaller and or bigger. Let's just move this guy over. Doesn't want to move. $25 or 24. It's compiling. We need a new crab now. If I just hit act, he goes 25 at a time. And of course, if I hit run, it does that multiple times, and you can't tell the difference really. And if you put multiple crabs in there, you will notice that they all do the same thing. And so on. You'll see the crab can now move across the screen. The move 5 instruction makes the crab move a little bit to the right. When we click the act button in the Greenfoot main window, the act method is executed once. That is the instruction that we've written inside the act method. Move 5 executes. The number 5 in the instruction defines how far the crab moves in each step. In every act step, The crab moves 5 pixels to the right. Clicking the run button is just like clicking the act button repeatedly, very quickly. The act method is executed over and over again until we click pause. If you want the crab to move left, I'll let you see if you can figure that out on your own, but I'll give you the answer right away. You can just pause the video right here. Okay, so I've got multiple crabs here. And let's just change that to -25. I'm sure you figured this out on your own. They move left. Terminology. The instruction move is called a method call. A method is an action that an object knows how to do. Here the object is crab, and a method call is an instruction telling the crab to do it. The parentheses and number within them are part of the method call. Instructions like this are ended with a semicolon. Okay, let's try turning. Let us see what other instruction we can use. The crab also understands a turn instruction. Here's what it looks like. Turn 3. Number 3 in the instruction specifies how many degrees the crab should turn. This is called a parameter. We talked about that in the previous chapter. We could also use other numbers like turn 23. The degree value is specified out of 360 degrees, so any value between 0 and 359 can be used. Turning 360 degrees would turn all the way around, so it's the same as turning 0 or not turning at all. If we want to turn instead of moving, we can replace the move 5 instruction with a turn 3 instruction. The parameter values 5 and 3 are picked somewhat arbitrarily. You can use different values. The act method would then look like this. So we're going to change the crab. So instead of moving 25, he's going to turn 3 degrees. And you can see they turn 3 degrees multiple times. If we just clicked act, they move 3 degrees and so on. If you want to make the crabs turn left, -3. And so on. The next thing we can try is to both move and turn. The act method can hold more than one instruction. We can just write multiple instructions in a row. Code 2.2 shows the complete crab class as it looks at the move and turn. In this case, at every act step, the crab will move and then turn. But this will happen so quickly after each other that it appears as if it happens at the same time. So we're going to put move 5 and turn 3 in there. Notice my indentations are a little bit there. Let's clean that up. What's this going to look like? So he's moving and turning at the same time. Page 22. So you can play with that. Exercise 2.8 talks about using different values for n and m. So you can play around with that. Terminology. The number between the parentheses and the turn instruction, the 5 and the turn 5 is called a parameter. Parameter is an additional bit of information that we have to provide what we call some methods. Side note, errors. When we write source code, we have to be very careful. Every single character counts. Getting one small thing wrong will result in our program not working. Usually it will not compile. This will happen to us regularly. When we write programs, we inevitably make mistakes and then we have to correct them. Let's try that out now. If, for example, we forget to write the semicolon after the move 5 instruction, we'll be told about it when we try to compile. So in exercise 2.9, it says, asks you to remove that semicolon. So go ahead and try that. You can pause the video if you need to. I also ask that you try misspelling things, try to make some other changes, try to make it crash, come up with different sort of error messages and play around with that a little bit. I suggest pause the video here. At the bottom of page 22. As we can see with this exercise, if we get one small detail wrong, greenfoot will open the editor, highlight a line, and display a message at the bottom of the editor window. This message attempts to explain the error. The messages, however, vary considerably in their accuracy and usefulness. Sometimes they tell us fairly accurately what the problem is, but sometimes they are cryptic and hard to understand. The line that is highlighted often is the line where the problem is, but sometimes it is the line after the problem. When you see, for example, a semicolon expected message, it's possible that the semicolon is in fact missing on the line above the highlighted line. We will learn to read these messages a little bit better over time. For now, if you get a message and you're unsure what it means, look very carefully at your code and check that you've typed everything correctly. Okay, page 23, dealing with screen edges. When we made the crabs move and turn in the previous sections, they got stuck when they reached the edge of the screen. Greenfoot is designed so the actors cannot leave the world and fall off its edge. How we shall improve this behavior so that the crab notices that it has reached the world edge and turns around. The question is, how can we do that? Above, we have used the move and turn method, so there might also be a method that helps us with our new goal. In fact, there is. How do we find out what methods we have available? The move and turn methods we have used so far come from the actor class. Crab is an actor, signified by the arrow that goes from crab to actor in the class diagram. Therefore, it can do whatever an actor can do. Our actor class knows how to move and turn. That is why our crab can also do it. This is called inheritance and is a key concept in object-oriented programming. The crab class inherits all the abilities, methods from the actor class. The question now is, what else can our actors do? To investigate this, we can open the actor class. You will notice when you open or double-click the actor class, it does not open in a text editor like the crab class, but shows some documentation in the web browser, like the one on the page. But again, that's a Macintosh environment. This is because the actor class is built into greenfoot. It cannot be edited. We can still use the actor's methods to call them. This documentation tells us what methods exist, what parameters they have, and what they do. We can also look at the documentation of our other classes by switching the editor view from source code to documentation, using the pop-up control on the top right of each editor window. But for actor, there is only documentation view. So what they're saying is if we click here under actor, you get all of the methods that actors know about. So it can get image, it can get, this is basically all the keywords in greenfoot, much like the keywords in Liberty Basic, or much like the menus, the tabs, or the palettes in Biob and Scratch. If you click on crab, you get the actual source code, but if you click here, you can see the documentation. Let's go back to the actor class. So exercise 2.11 says, how many methods does this class have? I suppose you can count them. There's several. Look through the list of methods available. Can you find one that sounds like it might be useful to check whether we are at the edge of the world? And I'll let you have a look. I suggest you pause the video here. Okay, so hopefully you found that. It's right here. It's called is at edge. And you click on it, it jumps down to here. So is at edge is a method that returns a Boolean value either true or false and detects whether the actor has reached the edge of the world. The actor is at the edge of the world. Their position is at or beyond the cells at the very edge of the world. For example, if your world is 640 by 480, the actor is at an edge of its act position is less than or equal to 0 or greater than or equal to 639. So back to page 24, if we look at the method summary, we can see all the methods that the actor class provides. Among them are three methods that are especially interesting to us at the moment. They are Boolean is at edge, void move, and void turn. Here we see the signatures for three methods as we first encountered them in chapter 1. Each method signature starts with the return type and is followed by the method name and the parameter list. Below it, we see a comment describing what the method does. We can see that the three method names are is at edge, move, and turn. The move and turn methods are the ones we used in the previous section. If we look at the parameter list, we can see that what we observed before, that they expect one parameter of type integer. For the move method, this specifies the distance to move. For the turn method, this is the amount to turn. We can also see that the move and turn methods have void as their return type. This means that neither method returns a value. We are commanding or instructing the object to move or to turn. The crowd will just obey the command and not respond with an answer to us. The signature for is at edge is a little different. It is Boolean is at edge. This method has no parameters. There is nothing between the parentheses, but it specifies the return value, Boolean. We briefly encountered the Boolean type in section 1.4. It's a type that can hold two possible values, true or false. Calling methods that have return values where the return type is not void, it's not like issuing a command, but asking a question. We can use the is at edge method. The method will respond with either true, which is yes, or false, no. Thus, we can use this method to check whether you're at the edge of the world. So in exercise 2.13, let's just go back here and create a crab. Right-click and find the Boolean is at edge method. It's inherited from the actor submenu since the crab inherited this method from the actor class. Call this method and what does it return? So let's click on this guy here, and we're going to find is at edge, and you can see that it returns false. Exercise 2.14, let the crab run to the edge of the screen or move it there manually, and then call the is at edge method once again, and what does it return now? So in other words, let's make this true. So if we run this, he's going to start running in a circle. Okay, so to make him hit the edge, we're going to have to move him over a little bit. There we go there. And let's just pause it when he's at the edge. Right click is at edge, and he returned. Oh, he's still returning false. So maybe he's got to be a little bit farther over. Still false. Let's take rid of that moving part. The turn part. Let's get rid of the turn. Let's just move him 5 so that he goes to the right. There we go. Now he should return. Now he's returned true. I'm reading in the book, page 25. We can now combine this method with an if statement to write the code shown in 2.3. This is the first time you've seen an if. So we're going to write here in our class, in our crab, under act, we're going to say, before we move, if, bracket, parentheses, is at if at edge returns true, brace it. This is like the then part. We're going to turn him 17 degrees. And this brace here is like the end if. And you'll notice that greenfoot does some of the indentation for us. Let's just clean that up a little bit. Greenfoot does have an option for auto indentation. You may have it turned on already. Indentation is always important. And so we're going to go like that. Yeah, that's a little easier to read. Okay, so reading the bottom of page 25. The if statement is part of the Java language that makes it possible to execute commands only if some condition is true. For example, here we want to turn only if we are at the edge of the world. The code we've written is if is at edge, and quite often I forget that other bracket there, but I've got it today, turn 17. And then we're going to move 5 regardless. And there's the general form of the if statement down there below. Oh yeah, let's see if this works. It says no syntax error, so that's a good thing. Put in a crab and let's run him. And he turned when he got to the edge. Yay. Reading on page 26. In place of the condition can be any expression that is either true or false, such as our is at edge method call, and the instructions will only be executed if the condition is true. There can be one or more instructions. If the condition is false, the instructions are just skipped and the execution continues under the closing curly bracket of the if statement, sort of like the end of or the end if in Liberty Basic. Note that our move 5 method call is outside the if statement. I'm just going to call that up on the screen. Okay, this is outside, so it moves regardless. So exercise 2.15, try it out if you haven't done so already. Exercise 2.16, experiment with different values for the parameter of the turn method. Find one that looks good, so go ahead and change to 17 as you please. And place the move statement into the if statement rather than behind it, and test it out. What's the effect? Explain the behavior you observed, then fix it again by moving it back to where it was. Okay, a little side note here. We're almost at the end of this lesson. Side note, scope coloring and indentation. When you look at source code in Greenfoot or in the code examples in the book, you will notice the colored boxes used for the background. These are called scopes. A scope is the extent of a given Java construct. In Greenfoot, different kinds of construct have been given different colors. A class is green, for example, a method is yellow, and an if statement is a purplish gray. You can see these scopes can be nested. An if statement is inside a method, and a method is inside a class. Pay attention, and you can see that here. Very similar kind of look to Scratch. Paying attention to these color scopes pays off over time. They can help you avoid some common errors. Scopes are usually defined in your code by a pair of curly brackets, usually with a header above the opening bracket that defines what kind of scope we're looking at. It can happen very easily to get the curly brackets out of balance, to have more opening than closing ones or vice versa. If this happens, your program will not compile. So very important here, far more important than it was in Liberty Basic. Scope coloring helps you to detect such a problem. You will get used to what the scope should look like quite quickly, and you will notice that it just looks wrong when a bracket is mismatched. Hand in hand with scope colors goes indentation. In all the code examples you've seen so far, you may have noticed some careful indentation being used. Every time a curly bracket opens, the following lines are indented one level more than the previous ones. When a curly bracket closes, the indentation goes back one level, so the closing curly bracket is directly below the matching opening bracket. This makes it easy to find the matching bracket, which is why I taught you the indentation in Liberty Basic. You'll notice that the curly brackets see how they're lined up like this? That's the way you want to do it. We use 4 spaces for one level of indentation. The tab key will insert spaces in your editor for one level of indentation. Greenfoot can also help you should your indentation get too messy. The editor has an auto layout function in its edit menu, which will try to fix the indentation for the whole class. So under edit, here you have auto layout, and it should help you. Taking care with your indentation in your own code is very important. If you do not indent carefully, the scope coloring will look messy, become useless, and some errors, particularly misplaced or mismatched curly brackets, are very hard to spot. Proper indentation makes code much easier to read and thus avoids potential errors. So exercise 2.18, open the source code for your crab class, and we've got it open right now. Remove various opening or closing curly brackets and observe the changes in scope coloring. For example, get rid of this one here, and you can see how the scope coloring changed immediately. In each case, can you explain the change in color? Also experiment with changing the indentation of brackets and other code and observe how it affects the look. At the end, fix the brackets and indentation so the code looks nice again. So just do some messing around here. For example, this will actually compile, I believe. No. Oh yeah, it did. Okay. And it should run. Remember, I've got that auto indentation on, but so it doesn't quite look quite as nice as it should. You want this sort of look kind of thing, very similar to Scratch, which is why I showed you that in grade 10. Okay, so once again, we've reached the end here. I suggest that you read through the summary of programming techniques to sort of summarize the entire chapter. There are some concept summaries on page 28 that you should be aware of. And then we're actually going to do a little assignment here. This occurs on the bottom of page 28. It talks about a fat cat scenario. Okay, you can, I suggest that you sort of read through the ones on page 29, the method signatures, read those exercises and maybe just try those out. Have a look at exercises 2.24 and to 2.26, but the real assignment is over on page 30. Okay, and if you have been following along on your worksheet, you should have this filled in. If you haven't, you should probably pause the video and go back and do that. And the assignment here is on the back. Okay, so it says assignment, open fat cat scenario, and save to your personal folder. So we're going to start with exercise 2.24. I lied a little bit. You're going to have to do that. Answer those 3 questions, and then complete exercise 2.27, which is on page 30. You will have a little bit of trouble with section 2.28. I did. You're going to have to read the source code for cat to help you out with that. I can help you with that as well. So exercise 2.33, I want you to make the cat do a routine of your choice. It must include at least 2 method calls and save it in your own personal folder. And then complete at least one of the exercises 2.34 to 2.38. Save that as well for 5 marks as well. And you'll get a score mark for chapter 2. Okay, so you've got some work to do. I will end the video and I will get on making chapter 3 video right away.